Now that we have a better idea of the three main macroeconomic banking variables, we want to go ahead and introduce a very large problem, get a little bit of practice. So I've drawn up a T account, a few questions, and then we're going to introduce a few dynamic changes to this balance sheet and see exactly how to solve out every question that we have right here. So first of all, we have assets, we have liabilities, we have an initial banking T account, we have cash, deposits to the Fed, loans, also deposits, and you notice that yes, the left-hand side does equal the right-hand side, so $100,000 equals $100,000. We are good to go. Anytime you see a balance sheet that does not balance, that means something has gone wrong with the bank and that you should probably go ahead and get a little bit more information. First question that we want to go ahead and ask is, what is the reserve ratio? So what is the reserve ratio? Remember how we calculate that out? That's going to be reserves divided by the total deposits that we have in the bank. So here we take a ratio. The bottom half, the denominator, is going to be easy. We just take a look at the deposits. It equals $100,000. So $100,000 of deposits, we put that straight into the denominator. And the numerator, we need to put in reserves. And what is considered reserves for the bank? Remember, two components are seen as reserves. It's cash, so vault cash, and also deposits at the Fed. You need both of these in order to get the entire reserves. So here, add those together. You have 2,500. We add in 7,500, and then we go ahead and simplify as much as we can. Here, we get 10,000 divided by 100,000, and this will give us a cool 10% reserve ratio. This just tells us that the bank is holding 10% of its deposits as reserves. Remember, reserves need to include both of these variables, cash and deposits at the Fed. Question number two, if the reserve requirement is 5%, how much must the bank hold in required reserves? So we have a reserve requirement of 5%. By law, this bank has to hold 5% of all of its deposits as required reserves. To do that, we just need to go ahead and multiply our reserve requirement multiplied by the total deposits. So here we have 5%, 0.05. You want to put this into decimal form. You multiply it by the total deposits, 100K. And then when you multiply these two together, you get $5,000. So here, the bank has to hold $5,000 as required reserves. This is the minimum amount it has to hold as required reserves. And you notice that, hey, its reserves from before were $10,000, so it is actually holding more than what is legally required. So they are meeting its reserve requirement. Final question that ties into what we just said, does the bank hold excess reserves? So yes, it does hold excess reserves because remember, they are legally required to hold a minimum of $5,000 in reserves and required reserves, but they're actually holding $10,000 as reserves. So it does have excess reserves. So when we take the difference between these two numbers, we have excess reserves. So 10,000 of reserves minus $5,000 of the required reserves, and this will give us $5,000 of excess reserves. And if the bank chose to do so, it could go ahead and lend out 5,000 additional more dollars if it wanted to, but it doesn't necessarily have to. So three very simple examples, three questions that we have with our first bank T account. Let's go ahead and introduce a few dynamic changes, however. So how would things change with all of these if someone withdrew $2,000 from their checking account? So someone goes to the bank and says, hey, I need $2,000 to pay for a particular good, so let me have my $2,000. And remember, the bank is going to have to be sort of obligated to give the person $2,000 because it is their obligation. So remember that when we put money into the banks, we are expecting to get our money back when we want it, and the bank should give us our money when we need it. So how are things going to change with our assets and with our liabilities? So first of all, how are the liabilities going to change? Before it had $100,000 of deposit, but once they give someone their $2,000, that means their liabilities have actually gone down. So therefore, they only have deposits or liabilities equal to $98,000. So $98,000. But that tells us that if we have $98,000 on the right-hand side, we should have $98,000 on the left-hand side as well. So where is this $2,000 going to come out of? Is it going to be cash, deposits to the Fed, or loans? So it really doesn't matter for the bank where it takes out the $2,000 if it comes from cash or deposits at the Fed. It does not touch the loan amount at all. So the loan amount rarely changes because if the bank actually takes takes the loans out, that means they're taking a loss on the loan. So these are things that the bank does not want to touch at all. So here, the loan amount still stays the same at $90,000 as we had on our very first T account. So in terms of cash or deposit to the Fed, because they are both seen as reserves, it doesn't really matter where the bank takes out the $2,000. It can be all from cash, it can be all from deposits at the Fed, or it can be a combination of these two. The problem will specifically tell you where to take out the money from these particular amounts in the reserves. Let's go ahead and say that the bank takes out $2,000 from the vault in the cash. So cash in the vault. So here it goes from $2,500 that we had before, and it goes down to $500. So the bank is taking out the full $2,000 amount from cash in the vault, cash in the vault, and not necessarily from deposits at the Fed. So let's go ahead and put down minus 2,000, which would be 500 right here. And then deposit at the Fed, because we haven't taken out any money at all, it remains the same. So we still have that same 7,500. And we check ourselves once again, the left-hand side. So 8,000 plus 90,000 will give us 98,000. That equals the right-hand side equals $98,000 as well. So we are good to go. Remember, it doesn't really matter where the bank takes out its reserves, but the problem will specifically tell you where to take it out. Here, we're taking it out all from vault cash. Next, let's go ahead and answer the same exact questions plus one additional one. So what is the reserve ratio now? So obviously the reserve ratio should go down because someone withdrew $2,000, so both the reserves and the deposits have fallen, so that tells us that the reserve ratio should also fall as well. Once again, we put the deposits in the denominator. This is going to be 98,000, no longer 100,000. We put the reserves in the numerator. It's going to be 500 plus 7,500. And then we simplify as much. It's going to be 8,000 over 98,000. And this will give us roughly about 8%, so about 8.16%. So before we had a reserve ratio of 10%, now we only have a reserve ratio of 8.16%. So the bank is holding 8.61% of all of its deposits as reserves. Once again, if the reserve requirement is 5%, so yes, we are meeting the reserve requirement because we noticed that, hey, our reserve ratio is greater than the reserve requirement. But what is the minimum amount the bank has to hold as required reserves? Once again, we take the reserve requirement, 0.05, and multiply it by our total deposits of $98,000. $98,000. So the bank is now obligated to hold $4,900 as required reserves. So by law, this is the minimum amount it has to hold. Is it meeting its reserve requirement? We've already said yes, because it had $8,000 in reserves, but only legally required to hold $4,900. So yes, once again, the bank does hold excess reserves, but it's going to be by a smaller amount compared to our first T account. So when we take our reserves, 8,000, minus our required reserves, 4,900, we will get our excess reserves, which is 3,100. So the bank, it had excess reserves of $5,000 before. Now it only has $3,100. From this, we can actually ask an additional question, and this just asks us the changes from balance sheet 1 to balance sheet 2, but there are a few mathematical sort of conventions that we can talk about as well. So by how much must the bank reduce its lending? Remember, anytime we talk about lending, we're talking about excess reserves. So another way that we can ask this question is, what is the change in excess reserves? Easiest way to go about this is to go ahead and take a look at the excess reserves from balance sheet number 1. Our excess reserves were equal to 5,000 from before. Our excess reserves in the balance sheet number 2 is 3,100. So when we go ahead and take the difference between these two numbers, 5,000 minus 3,100, we will get the change in our excess reserves, which is 1,900. So the bank actually had to reduce its lending ability by $1,900. But because there are relationships that do develop between all these variables, we can go ahead and introduce a mathematical way to show this as well. If you remember from before, we had the formula excess reserves equals reserves minus required reserves. So this was the formula that was given to you in order to calculate out the excess reserves. But mathematically, we can go ahead and introduce some type of differentials. So if we introduce the change on the left-hand side, the change on the right-hand side as well, it will hold the same equality. So this is something mathematical that you can absolutely do. Don't worry about the logistics or the derivation of it too much. Just take it as is. And this just tells us the change in excess reserves is equal to the change in reserves minus the change in required reserves. So essentially, what we are solving for is the change in excess reserves. So change in excess reserves. But do we know the change in reserves? And yeah, we do. We just go ahead and compare balance sheet number 1 to balance sheet number 2. And the change in our reserves, it went from $10,000 from before. So remember, we had $10,000 of reserves in balance sheet number 1. But we have $8,000 of reserves in balance sheet number 2 right here. So remember, cash and deposits at the Fed make up the reserves. So when we take the difference between these two, 10,000 minus 8,000, we have a change of reserves equal to $2,000. So remember, change means we're taking some type of difference. Change in reserves is not the same as reserves. So we've talked about this several times throughout the semester, so hopefully that point has gotten across. And then we want to go ahead and subtract out the change in required reserves. So before we had to hold $5,000 in required reserves, now we only have to hold it $4,900. So the change in required reserves, taking that difference, is $100. And when we take the difference between the change in reserves and the change in required reserves, we get the same amount of $1,900. So essentially, once again, there are a lot of different ways to approach these type of problems because there are relationships that do develop between all of these variables. But once again, use the information that is being provided to you in order to solve all these things out. With this is actually the biggest component that we have in this particular chapter, just taking a look at these balance sheets and solving for these 3 banking variables, as well as introducing a few changes to the balance sheet as well. So I would encourage you to go ahead and get a lot of practice using these type of problems. What happens if we go into the opposite case? So what happens if someone actually put in or deposited an additional $2,000 into this checking account? How would all of these things change as well? So once again, there's a lot of different ways that you can go ahead and get a lot of practice, change the numbers up just a little bit, ask the opposite case, but you're always going to have enough practice and exposure to go ahead and answer all of these questions. With all of this in mind, we can go ahead and introduce the fractional reserve banking system that the United States and also that the European Union also sort of uses as well, in order to see how much money can actually be created from one initial deposit into a bank. So work with the entire transition in the next section.